We learned about the basic integration rules in the first part of this lesson, and on this one, we are going to learn the integrals of the functions e to the x, ln x, sine x, and cosine x. We learned in differentiation that d dx of e to the x is equal to e to the x. So when we do the opposite process, the integral with respect to x of e to the x would then also be just e to the x, but plus c. We also learned that when the exponent of e is not just x, but some other function in x, so e to the power of f of x, then the derivative would just be e to the power of x. Using the chain rule, we got that the derivative would be e to the power of f of x times whatever is the derivative of f of x. The opposite of this process in integration, however, only works when f of x is of the form ax plus b. So what happens is we can get the integral of e to the power of f of x, but only when f of x is equal to ax plus b. And we can differentiate this with respect to x using the opposite process. So first, it will just be e to the power of ax plus b. The opposite of multiplication is division. And then because our f of x is ax plus b, f prime of x, the derivative, will just be a. And then we will have our c here. So for example, if we get the integral of e to the power of 5x plus 2, then it will just be e to the power of 5x plus 2 divided by the derivative of 5x plus 2, which is 5, and then plus c. Or we could write this as 1/5 e to the power of 5x plus 2 plus c. Similarly, if we get the integral of 3e to the power of, let's say, negative x over 2, let's rewrite this as 3 integral of e. Let's write negative x over 2 as negative 1/2 x. So that is indeed, the exponent of e is indeed in the form ax plus b, in which case a is negative 1/2 and b is 0. So the integral would be e to the negative 1/2 x divided by negative 1/2 plus c. So we could just simplify this a little bit more, because 3 divided by negative 1/2 would just be negative 6. And then maybe we could put back negative 1/2 x to negative x over 2 and then plus c. Next is the derivative of ln x. We learn in differentiation that d dx of ln x is equal to 1 over x. So the equivalent of that in integration will be the integral, the opposite process will be the integral of 1 over x dx will then be ln x plus c. We also learned that if we get the derivative of not just ln x, but ln of some function in x, then that would be equal to 1 over f of x. Using the chain rule, it's 1 over f of x times whatever is the derivative of f of x. And with integration, just like what we did earlier with e to the power of x, the opposite process of this will only work if f of x is of the form ax plus b, which means that we can get the integral of 1 over f of x when f of x is ax plus b. And it will just be ln ax plus b. And instead of multiplying it by f prime of x, we divide by f prime of x. And because our f of x is ax plus b, and the derivative of ax plus b is a, so we divide this by a. But a better way of writing this will be ln ax plus b over a. And let's not forget our plus c here. So the integral of 1 over 4x plus 5 would then be ln 4x plus 5 4 plus 4x plus 5. If you get the derivative, the answer is 4, and then plus c. But it is better to write this as 1/4 ln 4x plus 5 plus c. Similarly, if we have the integral of 4 over 1 minus 2x dx, let's rewrite this first as 4 integral of 1 over 1 minus 2x dx. So now the integral is ln 1 minus 2x divided by negative 2, because the derivative of 1 minus 2x is negative 2, and then plus c, and that could be simplified as negative 2 ln 1 minus 2x plus c. Next, for sine x, we learned that ddx of sine x is equal to cos x. So the opposite of that would be the integral of cos x dx would then be sine x. We also learned that we get the derivative of sine of not just x, but some function in x. And we can use the chain rule, and we came up with cos f of x times the derivative of f of x. And just like the previous two rules, the opposite of this process will only work if f of x is in the form ax plus b. So the integral of cosine ax plus b will be sine ax plus b, and instead of times f prime of x, we will be dividing. And because our f of x is ax plus b, f prime would be a. Again, it's better to write this as sine ax plus b divided by a. Let's take an example. The integral of cos 3x plus 2 will then be sine 3x plus 2 divided by the derivative of 3x plus 2, which is 3. And that would just be, and then plus c, which is just 1/3 sine 3x plus 2 plus c. This next one, derivative or integral of 2 cos x over 2 plus pi. Now remember that pi is just a constant. Let's rewrite this a little bit. Let's do 2 times the integral of cosine. Let's write x over 2 as 1/2 x plus pi. So this will just be 2 times sine 1/2 x plus pi all over 1/2. Remember that pi is just a constant, so the derivative is 0. So sort of goes away. And we have our plus c here. So we can just simplify this as 2 divided by 1/2 is just 4. So 4 sine Let's write that back as x over 2 plus pi plus c. Okay, this is the last one. In differentiation, we learned that the derivative of cosine x is equal to negative sine x. So the integral of sine x will then be negative cosine x plus c. And we also learned that d dx of cosine f of x, using the chain rule, we get negative sine f of x times f prime of x. So this is very similar to the previous one. It also still works for when f of x is ax plus b. So when we get the integral of sine ax plus b, it will be negative cosine ax plus b divided by a. So if we get the integral of sine 5 minus 3x, it will just be negative cosine 5 minus 3x over negative 3, which is the derivative of 5 minus 3x, plus c, or write this down as positive 1/3 cosine 5 minus 3x plus c. So similarly, if we have 4 sine 2x, get the integral. Let's rewrite that first as 4 sine 2x dx. So that's just 4 times negative cosine 2x over 2 plus c, where that is just 2, negative 2 cosine 2x plus c.